Hello, this is Advent of Code 2024. I'm Noah Mann. I'm the author of FunctionalJ.io, which is the Java library that brings functional goodies to Java. Allow us to write more functional static code in Java. Today's puzzle is day 13. All the code discussed in this video and the link to what mentioned earlier will be in the video description. In today's puzzle, we will pause our mission of looking for the chief historian and have some fun with the claw machine. The claw is a little bit unusual. You'll be paying 3 tokens for every time you push A button and 1 token for every time you push B button. And not only that, the machine will move the claw by a certain amount. So the first machine over here, every time you push A button, it will move by 94 units on the x-axis and 34 on the y-axis. Every time you put the B button, you will move the claw by 22 units on the x-axis and 67 units on the y-axis. And you need to move to price, which is located at the 8400 unit on the x-axis and 5400 unit on the y-axis. In this example, there are 4 different separated machines. So the question is to figure out whether or not we can press A and B using this configuration to get to the price, and what is the amount of time that we're going to press A and the amount of time that we're going to press B that use the least token to get to the price. In this example, we will have to press A 80 times and B 40 times in order to have the claw move along X and Y axis to end up at the 8400 and 5400 position where the price is. And because every time we press A, we pay 3 tokens. So we pay 80 times 3 for the A button and 40 times 1 for the B button because we pay 1 token for the B, which total of 280. For the second and fourth claw machines, it is not possible to get to the price. So why do they put it in the arcade? I don't know. So we cannot get the price there. But for the third machine, it will require to press A 38 times and B 84 times. So the cost to do that is 200 tokens. So when we sum these two together, we got 480, which is the answer for this example. All right, this puzzle, part 1 and part 2 are actually the same question, just different number. For part 2, we will have to add this extra number into the price for both X and Y axis. So the problem becomes something like this. Another word, for day 13, the problems are the same, just a different scale, which make it harder to calculate if you are not optimized. Since I want to use this video to showcase functional J, if I do this programmatically, it would take a long time for us to add these things up to end up here. So the optimized solution is not a programmatical way. We can solve this problem using algebra. So it's not exactly a programming puzzle. But since I'm committed to solve this question, if I can, I'll move forward and explain you how do we solve this question. As I said, it is algebra question. Alright, so if you are interested only programming problem, then, well, thanks for watching. See you later. But if you want to know how to solve this using algebra, then keep watching. It's not that hard. We need to first define problem mathematically. So let's start with the first equation. A, which is the number of time we're going to press the button A, multiply with AX, which is the distance on the x-axis when we press A button, right? When we plus this with B times BX. So when we press B amount of time, it go with the distance on the X. It must equal to the location of the price on the x-axis. Second equation will be A times AY
plus B times BY have to equal to BY.
Alright, so from here, we need to try to figure out what A and B is. And we can do it in 2 ways. We can first try to figure out what A is and use A to create a B. Then we will get a pair of A and B. Then we can calculate the cost, because the cost will be 3A and plus B. And then we can revisit again. In case number 2, we try to calculate B first, then use the B to calculate the A, and we calculate another cost. which one is lower, then we get our answer. But how can we do that? So we will first try, so we will calculate the first case first, calculate for A. So we do that by trying to eliminate the B term, and that's done by make sure that the coefficient, the time B are the same for both equations so that we can subtract them and the B is gone. So we will time equation 1 with by, and then we time equation 2 with bx. This way, the b term will be the same, which is bx times by, and at the bottom it will be bx times by as well. So let's try that. Ax times by plus bx and by equal to px and by. See, we time the first equation, every term in the first equation with by. Then we time everything, we time everything in the second equation with bx. Okay, once we got that, we just subtract them. So this term will be eliminated. Now we get A. So now we can divide it all term with this. So we can calculate A, which will be equal to Px. Then we can calculate A, then we can calculate B using this equation. So it will be Px minus A times Ax divided by Bx. Once we got those two, we can calculate the cost. And then we do the opposite. Instead of it try to eliminate B, instead of trying to eliminate B, we'll try to eliminate A instead. So let's take a look at the code. To make the code more eligible, I create a type called AB, which represents how many times we press A and how many times we press B. Then there's a type AY, XY, which represent the distance of X and distance of Y for any bundle. And there's a convenient method to parse it from the input. And then there's a convenient method to apply long operator to each of the X and Y element. Alright. Then a game will contain a button A, button B, the price, and the cost. By button A, I mean the distance of X and Y when we press button A, and button B is the distance of X and Y when we press button B, and price is the location of the price on X and Y axis, and cost is number of time we press A and number of time we press B. Then we can calculate the mean cost by calculate the first cost first, by calculate the first cost, which is to find A first, and calculate the second cost when we try to find B first. So the first cost look like this. Because we try to find A first, we do all the calculation I just showed you earlier. Then we can calculate A. Then use the A to calculate B. Check if the A and B can get us to the price. If it is, calculate the cost of A and B. Otherwise, it will be the maximum value. We do the same, but do the B first, and then do the A. Check if it's valid. Another word, check if it can get to the price. And then if it is, then we return the cost of A and B. The cost of A and B is the cost of A times A, the cost of B times B. To check if it's valid, it just A times 1x moving along the x-axis plus B times when we press 1B and it moves the x along the axis equal to the location of the price on X. Same go with Y. Then we can create a new game from the input and the cost. because in the second part, we will need to adjust the price by a trillion. Then we can calculate it by set up the cost of each button and then set up the adjustment. Then we can calculate the sum of the cost that we can get, which is correct here. And then for part 2, we just set the price offset to the million and calculate as normal. That is it for this puzzle. Please click like, share, subscribe, or comment if you have. Thank you for watching. Bye bye.